In this screencast, we're going to talk about partial derivatives and the derivative. It turns out to be a matrix. So first, let's start with just an example. If you've got a function, f of x is x squared. When you take the derivative, well, you bring the 2 down, subtract 1 from the power, and that's it. That's our simple way of taking derivatives we learned in first semester calculus. Well, what if the function has a vector as an output, say an x squared and an e to the 3x? How do you take derivatives? Well, the idea is take the derivative of each of the components of the vector. So we've got a 2x and 3 to the 3x. Now, you're going to find as we go, if you always think of functions as having columns, vectors as their outputs, then when we take derivatives, things are going to turn out to be a little bit simpler when we try and deal with organization. So we'll just write everything in terms of columns. Well, you can also do the same thing if you have a function that has lots of outputs. So you've got an x squared, a cosine x, and a tan inverse of x, and you want to take the derivative. And then you just take the derivative of each component. Negative sine x is the derivative of cosine, and then 1 over 1 plus x squared is the derivative of tan inverse. So our key is in this class is really just learning about how to organize material. If you've forgotten some of your derivatives, you'll be okay. What we're going to do now is we're going to change things, and we're going to say, what if you have a function that has more than one input and then has an output? So let's go x squared y cubed. How do you take a derivative of this function? Well, over here there was only one variable to take a derivative with respect to, but over here we have 2 variables. So I could take a derivative of the function with respect to x, or I could take a derivative of the function with respect to y. The symbol we're going to use is, rather than using a d, it's kind of a curly d. It's read partial. So this is the partial of f with respect to x. And the idea is take the derivative with respect to x, but hold y constant. This one is differentiate with respect to y, but hold x constant. Some symbols, people often write this with an f and then a little x next to it, and this f with a little y next to it. F sub x, f sub y, the partial of f with respect to x. Let's just look at this function and compute some things. If I take the partial of f with respect to x, I get out, well, think y is a constant. So if you had an x squared times a constant, and you wanted to take the derivative, then it's just 2x times the constant. So this is 2x, and leave the y cubed alone. If I want the partial of f with respect to y, then the idea is we'll leave the x as a constant, and we now have a y cubed, and we want to take a derivative, so that becomes a constant times the 3y squared, and the constant was x squared. And we'll leave the 3y squared in now. So what is the derivative? These are called partial derivatives of f. They're partial derivatives. The derivative of f, often written with a big D, the derivative is you take the partials. So these partials, we had 2xy cubed, and we had an x squared, 3y squared. The partial derivatives form the columns. Partials go in columns of a matrix. So there's an x column and a y column. Well, I'm going to change the function now, and we're going to look at a bigger function. Suppose the function is f of xy equals 3x 2xy squared, and then x plus x squared y. So in this function we have 2 numbers we're putting in. We have a vector, a 2-dimensional vector we're putting in, and we're getting out something 3-dimensional. So I can take the partial of f with respect to x. When I do so, if I think of this as a column, then I get a derivative here with respect to x is 3. The derivative here with respect to x is, remember, the y is a constant. So the derivative of 2x is just a 2, and the y squared is a constant. I'll leave it alone. And now the derivative with respect to x is 1 plus, they bring the 2 down, so I've got a 2x, and the constant y stays there. That's the partial of f with respect to x. What's the partial of f with respect to y? Well, the partial of f with respect to y is, the derivative of this with respect to y is 0. It's a constant. Here, the 2x is a constant, so I bring the 2 down, giving me a 4xy. And here, there's a 0 plus the x squared stays there. So the derivative of this function is a matrix. And the matrix is 3, 2y squared, 1 plus 2xy, 0, 4xy, x squared. Derivatives are matrices, and the columns of each matrix are precisely the partial derivatives with respect to the different variables. That completes the screencast.